Alright, perfect problem 6 solutions. I don't know if I'll be able to fit this all on one page, but I'll try. First, it gives us a polynomial. F of x equals negative 6x to the fourth minus 23x squared minus 19x, 23x cubed minus 19x squared plus 8x plus 4. First thing it wants us to do is determine the end behavior of this polynomial. Because the term of highest degree here has an even exponent, that means it's going to go in the same direction as when it goes to the right as it goes to the left. Because it's negative, it's flipped upside down. What I'm trying to say is when we go to the right, we're going to go down. When we go to the left, we're also going to go down. So one way you could state the end behavior is by writing this mess right here. There's part one. Part two, I might squeeze that in up here also. Determine the y-intercept of this polynomial. The y-intercept happens when x equals 0. So I get 0 minus 0 minus 0 plus 0 plus 4. In other words, the y-intercept is 4. Or if you want, it's at the point 0, 4. Either of those are fine. I don't care. Alright, those are the easy parts. Now it gets harder. Part 3. Using the rational root test, list all possible x-intercepts of this function. So the rational root test tells me that possible, not necessarily the x-intercepts, but the possibilities for them, are integer factors of my constant term, 4, divided by integer factors of my leading coefficient, which in this case is negative 6. So I can either have, let's see, the factors of 4 are plus or minus 1, plus or minus 2, and plus or minus 4. Factors of 6, negative 6, either way, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So what that's saying is the only possible roots are any of these 6 numbers divided by any of these 8 numbers. So plus or minus 1 divided by 1, plus or minus 2 divided by 1, plus or minus 4 divided by 1, plus or minus 1 divided by 2, plus or minus 1 divided by 3, plus or minus 1 divided by 6. I wrote these in a horrible way. Let me try this again. So I'm going to do each of the numbers on top divided by, so 1, 2, and 4 over 1, and then 1, 2, and 4 over 2, plus or minus 1/2, plus or minus 2/2, but I already have that written here. Plus or minus 4/2, but I already have that written here. And then each of these numbers divided by 3, so plus or minus 1/3, plus or minus 2/3, plus or minus 4/3. And then each of these numbers divided by 6, so plus or minus 1/6, plus or minus 2/6. I already have that here because that's 1/3. Plus or minus 4/6. I already have that here because that's plus 2/3. So this is my complete list of the possible x-intercepts. All right, that was a pain. Number 4 says, test to see if x equals negative 2 is a root of this function. Hint, it is. The way you test that is you look at f of negative 2. If it equals 0, that means it's a root. It's an x-intercept. So let's try it. Negative 6 times negative 2 to the 4th power. Ooh, that's going to be a lot. Minus 23 times negative 2 to the 3rd power. Minus 19 times negative 2 squared. Plus 8 times negative 2 plus 4. So let's see, negative 2 to the 4th power is 16. So I have negative 6 times 16. Negative 2 to the 3rd power is negative 8. Negative 2 squared is positive 4. And I guess nothing to do here. Negative 2 and 4. So now if I multiply these numbers, negative 6 times negative 16 is negative 96. Negative 23 times 8 is positive 184, I think. If you do 23 times 8, I think you get 184. Because 25 times 8 would be 200, but we're 2 short of 25, so we have to get rid of 2 of those 8s. We have to get rid of 16. 200 minus 16, 184. 19 minus 4 is 76 on the negative side, because 20 times 4 is 80, but we're not quite there. We only got 19, so we have to get rid of one of those 4s, so we get 76, and it's negative. Minus 16 plus 4. When you add up all these numbers, hopefully you get 0. Should I just trust that I did it right? This is 188 on the positive side. And then negative 76 and negative 16 is negative 92. Negative 92 and negative 96 is negative 188. So same thing. Good, we get 0. Awesome. I don't know, check. Because f of negative 2 is equal to 0, I have that negative 2 is a root of this function. If negative 2 is a root of this function, then that means x plus 2 is a factor. X plus 2 is a factor, I can do x plus 2 divided by this function, negative 6x to the 4th power minus 23x to the 3rd power minus 19x squared plus 8x plus 4, and it should divide evenly. Well, let's see. If I want to get rid of negative 6x to the 4th, I'd have to put a negative 6x cubed here, because negative 6x cubed times x gives me negative 6x to the 4th. Negative 6x cubed times 2 gives me negative 12x cubed. And now what I do is subtract. Negative 6x to the 4th minus negative 6x to the 4th is the same as negative 6x to the 4th plus 6x to the 4th. It's 0. Negative 23x cubed minus negative 12x cubed is the same as negative 23x cubed plus 12x cubed, which is negative 11x cubed. And then I got this minus 19x squared plus 8x plus 4. Now I repeat. I want to get rid of negative 11x cubed, so up here I put negative 11x squared. Negative 11x squared times x is negative 11x cubed. Negative 11x squared times 2 is negative 22x squared. I subtract. This goes away. Good. Negative 19 minus negative 22 is the same as negative 19 plus 22, which is 3. Now I want to get rid of this 3x squared. Better put a 3x up here because 3x times x is 3x squared. 3x times 2 is 6x. If I subtract, these go away, and this leaves me with just 2x. So to get rid of this 2x, I'll put a 2 right here. 2 times x plus 2 is 2x plus 4. 2 times x plus 2 gives me 2x plus 4. I get a 0. That's good. I better get a 0. I made a mistake. So what did it want me to do? Use polynomial long division to express this function as this product. So I just figured out that this divided by x plus 2 equals this. In other words, my function f of x, my polynomial, is equal to x plus 2 times negative 6x cubed minus 11x squared plus 3x plus 2. I'm starting to factor this thing. It's a lot of work just to factor it a little bit and still be left with this mess. But we're heading in the right direction. This is part 5. Part 6. Using the rational root test, list all possible x-intercepts of what was left over, of what's in the parentheses here. So using the rational root test, I get that possible x-intercepts are factors of my constant term, which is 2, divided by factors of my leading coefficient, which is still negative 6. In other words, it's plus or minus 1 or plus or minus 2 divided by plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. It is, let's see, 1 over all of the, or all of 1 or 2 over 1, 1 or 2 over 2. So that gives me 1/2 and 2/2, but 2/2 I already have. 1 and 2 over 3. And 1 or 2 over 6. 1/6 and 2/6, but 2/6 I already have. That's right here. So here are all my possible x-intercepts that are left. And so what I can do is test to see if x equals -2 is a root of this mess. All right, so we're kind of repeating things here. 7. I can figure out that maybe if I call this thing g of x, I could do -6. I can figure out g of -2. What I'm saying is change all these x's into -2's. -6 times -2 cubed minus 11 times -2 squared plus 3 times -2 plus 2. Hopefully that equals 0. Let's see, this is -6 times -8. This is -11 times +4. So what I get is +48 minus 44 minus 6 plus 2. I got 50 and I got -50. I get 0. That's a good thing. That means that -2 is a root. If -2 is a root, x plus 2 is a factor. We can do polynomial long division again. There's no way I'm going to squeeze this all in. Alright, well, whatever. Keep going, see what happens. Polynomial long division. Do x plus 2 divided into -6x cubed minus 11x squared plus 3x plus 2. To get rid of -6x cubed, I'd put a -6x squared here. That would give me -6x cubed minus 12x squared. And if I subtracted, -11 minus -12 is the same as -11 plus 12. It's just 1x squared plus 3x plus 2. If I want to get rid of 1x squared, I got to put 1x up here, because x times x is x squared. X times 2 is 2x. And if I subtract here, 3x minus 2x is just x. I get x plus 2. Get rid of this x by putting a 1 here. 1 times x plus 2 is just x plus 2. And if you subtract, you get a 0. That's good. What that means is that f of x is equal to x plus 2 times x plus 2 times -6x squared plus x plus 1. I had this x plus 2, which went here, this x plus 2, which goes here, and then what's left over is this. Number 9 says, finish factoring this mess here. So to factor, I don't know where, right here, to factor -6x squared plus x plus 1, I want to find two numbers that multiply to -6, the product of a and c, and add to 1. So those are +3 and -2. And then I replace this plus x in the middle with plus 3x minus 2x. Then I can factor by grouping. Pull out a 3x from the first two terms, maybe a -3x if you want. Doesn't really matter which one you pull out. I'll leave it as just 3x. That'll leave you with -2x plus 1. I already got a -2x plus 1, so just pull out a +1. I'll leave you with -2x plus 1. And so what I have is -2x plus 1. Factor that out, and you just get 3x plus 1. So finish factoring. What I get is that f of x is equal to x plus 2 times x plus 2 times this times this. 10 says, state all the x-intercepts and their corresponding multiplicities. So for 10, I got an x-intercept at -2. That had a multiplicity of 2. I got, when this equals 0, set this equal to 0, subtract 1 from both sides, divide by 2. I got an x-intercept at +1/2 with a multiplicity of 1. And then I got an x-intercept at -1/3, because if you set this equal to 0, subtract 1, divide by 3, and that's also got a multiplicity of 1. I'm almost done. I just got to sketch a picture. I don't know where the hell I'm going to sketch it. Could do it right over this whole thing. I'm not going to do that. Sketch a graph that shows all your answers. Maybe I can do it in here. Here's 11. What color would I do this in? Maybe I need a new color. Let's do it in black. 11. Here's your graph. I want to come up with the graph that has this end behavior goes down on both sides, has a y-intercept at 4. 1, 2, 3, 4. Well, let's go through this point right here. It has x-intercepts at -2, -1/3, and +1/2. So there's 1, there's 2, there's +1/2. So I want it to go down on both sides. I only want it to bounce off my root at -2. So bounce here, go through these two. So what I'm saying is come up here, bounce off, go through this guy and through this guy, and then back down and through this guy, and then have the arrow end up pointing down. Graph should look something like this. Maybe you did it on more than one piece of paper because this is a mess. But at least I got all the answers in there somewhere. Maybe I'll call that good and end the perfect problem there.